Hello everyone, myself PIYUSH and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. And the name of subject is Microprocessor and Microcontrollers, which comes in third year, 6th semester. Right now we are discussing the chapter number 6, that is 8051 Microcontroller Architecture. And this is the module number 6.1. So in this video lecture, we are going to see the introduction to MSC51 family, then after important features and its application, that is important features and applications of 8051 microcontroller, followed by the memory architecture and 8051 pin configuration and 8085 microprocessor function units. So now first, we are going to start with the introduction to MSC51 family. Now, the Intel MSC51 commonly termed as a 8051. So, what is the name term? That is MCS51, that is also called as a 8051, is a single chip microcontroller, that is MCU series developed by the Intel in 1980 for the use of embedded system. So we are using on the embedded system while we already developed by Intel, that is 8051. The architecture of Intel MCS51 instruction set was John H. Wharton's. Intel's original version were popular in 1980s and early 1990s and enhanced binary compatibility derivatives remain popular today, and it is an example of complex instruction set computers and has separate memory space for program instructions and data. Next, we are going to see the important features and applications. So, what are the important features of 8051 and its applications that we are going to see? So, the 8051 architecture provides many functions, that is central processing unit, or we can call it as a CPU. Then after random access memory, that is RAM, and read-only memory, that is ROM, followed by the input output, that is IO device or input output ports, and serial ports that are for the communications and interrupts control and timer in one package. So all these things we are going to get in one package, that is on the controller, that is 8051. Now 8-bit architecture arithmetic logic unit, that is 8-bit ALU, that is our arithmetic and logic unit, and accumulator. Then after 8-bit register, one 16-bit register with special move instruction, and 8-bit data bus, and 2 cross 16-bit address bus, that is 2 bus of 16 bits, okay, and program counter, data pointer, and related 8, 11 or 16-bit operations. Hence, it is mainly an 8-bit microcontroller. Now, these all are the features of our 8051 microcontroller. Now, Boolean processor with 17 instruction, 1-bit accumulator, 32 register, that is 4-bit addressable and 8-bit. Okay, 4-bit addressable and 8-bit addressable, and up to 144 special 1-bit addressable RAM. So we are addressable RAM, that is 1-bit addressable RAM, and that is variable. So 18-bit addressable 8 bits. Now next one, that is the multiply, divide, and compare instruction we can easily perform on our microcontroller. Then after 4 fast switching register banks, 4, that is 4 fast switching register bank with 8 register of each memory. So in each memory we have 8 register, and that type of 4 total bank we have, that is memory map. Then after fast interrupt with optional register bank switching, that can be also possible in 8051. Then after interrupts and threads with selectable priority. Then after 128 or 256 byte of on chip RAM, or we can call it as inbuilt RAM, okay, and dual 16-bit address buses. It can access up to 2 into address to 16 memory location, that is 64 kilobytes, or we can call it as a 65536 locations each ROM, or we can say PMEM. External ROM, that is XROM. X is for the external terms, okay. On chip ROM, that is not included in 803X. X means any variable, that is 8032 or any other variables, okay. And 4 8-bit bidirectional input output port. we have total 4 bidirectional input output port and bit addressable, and UART, that is the serial port for telecommunication, or you can say any kind of TX and RX receiving and transmitting the communication lines. Then after two 16-bit counters that we have, and power saving mode in some derivatives. Then after one feature of the 8051 core is the inclusion of boolean processing engine, which allow bit level boolean logic, okay, which allow us bit level boolean logic operations to be carried out directly and effectively on the selective internal registers ports and selecting RAM locations. So we can also perform this kind of operation in our 8051 microcontroller. Now next we are going to see, that is the memory architecture. So what are the memory architecture? So the MCS51 has 4 distinct types of memory, that is internal RAM, then after special function register, then after program memory and external data memory. So these 4 are the total different types of memory available for our MSC51 family. That is first one, that is the internal RAM, second one, that is the special function register, third one, that is the program memory, and fourth one, that is the external data memory. Now the 8051 is designed as a modified von Neumann architecture that we already studied in our first lecture, or we can say first chapter, that is von Neumann architecture, with segregated memory, that is data and instruction. It can only execute code fetched from the program memory and has no instruction to write to the program memory, which is similar to the Harvard architecture. Okay, so over here we have already seen two different terms, that is von Neumann and Harvard architecture. Next, that is the internal RAM. So what is internal RAM, or we can say IRAM? Internal RAM or IRAM has a 8-bit address space using addresses 0 through the 0xFF, that is IRAM from 0x00 to 0x7F. Okay, so what are the location in IRAM? That is 0x00 to 0x7F can be accused directly, okay, and using an 8-bit absolute address that is part of the instruction. Now alternatively, IRAM, or we can say internal RAM, can be accessed indirectly. The address is loaded into the R0 or R1 and the memory is accessed using @R0 and @R1 syntax. So whatever the location, okay, over here we need to understand one thing, the address is stored inside of this R0 or R1. Suppose we are storing the location of 51H, right now we are storing the location of 51H, and we need to find what are the data that are available in the memory of the 51H. So if this is our memory and if this is our 51H, at that time we are storing this data, that is the 51H, into the R0 or R1, and from that we can get, or we can say @R0. It means it is going to find what are the data, not what are the address, not the data only. So if we are only considering R0, it means it is going to consider it as a data, but whenever we are writing @, it means it is the address from where we need to see into the memory location of that address. Okay, so 51 is the address, so at this address we have some data in our memory location, and that data can be fetched into the instruction. Now the original 8051 has 128 byte of IRAM. The 8052 added IRAM from 0x80 to 0xFF, which can only be accessed indirectly, and direct access to this address range goes to the special function register, and most of the 8051 clone have also have the full 250 bytes of IRAMs. Okay, then after special function registers, so special function register, or we can call it as a SFR, are located in the same address space as IRAM at the address of 0x80 to 0xFF, and are accessed directly using the same instruction as for the lower half of the IRAM, and they cannot be accessed indirectly via @R0 or @R1, which is not possible in special function register. Okay, and indirect access to this address will access the secondary half of the IRAM, and 16 of SFR, that is the special function register, those who address are multiplexed of 8 bit, are also bit addressable, that is for the special function register. Next, that is the program memory. So the program memory or PMEM, that is program memory, through less common is uses than IRAM, because it is not that much common, but IRAM is very much common, and XROM, that is the external ROM, is very common, is up to the 64 kilobytes or of read only memory. Now, starting at address 0 in the separate address spaces, it may be on or off chip. Okay, it may be on or off chip, that is the program memory, depending on the particular mode of chip being used. And program memory is read only through some variants of the 8051 use on chip flash memory and provide a method of reprogramming the memory in system or in applications. In addition to the code, it is possible to store read only data such as lookup table in program memory are retrieved by the move c a at the rate a plus dptr, that is the data pointer, or move c, that is a at the rate a plus pc, that is program counter instruction, and the address of compute as a sum of 8-bit accumulator and a 16-bit register, that is program counter or data pointer. So over here accumulator is a 8-bit register and the data pointer, or we can say the program counter, is 16-bit registers. Next one, that is the last one, and we can call it as a external data memory. Now external data memory, or we can say XROM, is a third address space, also starting at address 0 and allowing 16-bit of address spaces. Now it can also be on or off chip. Okay, it can also be on or off chip. What make it external is that it must be accessed using the MOVX. MOVX means move external instruction. Many variants of the 8051 include the standards of 256 byte of IRAM plus the few kilobytes of XROM on the chip. And the first 256 byte of XRAM may be accessed using the MOVX-A at the rate R and MOVX-A at the rate R1, MOVX at the rate R0A, and MOVX at the rate R1A. So these are the different configuration of the accessing the external RAM. The full 64 KB may be accessed using the MOVX-A at rate DPTR. So that is the 16-bit address, and over here also data pointer is also 16-bit address. So we can also move this type of instruction in the external data memory. Now we are going to see the 8051 pin configuration. So here are the listed pin configuration of 8051. So first one, that is the 8-bit data bus, then after 16-bit address bus which can address up to 64 kilobytes. Okay, then after a 16-bit program counter that we already know, then after 16-bit stack pointer, and 6 8-bit registered arranged in pair, that is BC, DE and HL. It is same as a microprocessor. And next one, it also required the supply, so 5-volt supply to operate, and 3.2 megahertz single pulse signal pulse clock. Okay, so it is required for operation of our microcontroller. So 8085 microprocessor function units. So here are some function units. So accumulator. So first one, it has 8-bit register used to perform the arithmetic logical units and input output and load and store the operation. So basically accumulator required perform all the different kind of arithmetic and logic unit, or we can say ALU functions, and input output or load or store the data that through the accumulator, and it is connected into the internal bus and ALU. Now arithmetic and logic unit. What is arithmetic and logic unit? As the name suggests, it performs the arithmetic and logic operation like addition, subtraction, and or XOR, etc. on the 8-bit data. Now next one, that is the general purpose register. So there are 6 general purpose register in 8051 processor. So B, C, D, E, H and L, each register can hold up to 8-bit data, and those registers can work on the pair to hold 16-bit data, and their pair combination be like BC, DE and HL, that can be its 16-bit pair. Next one, that is the program counter, or we can call it as a PC, program counter, that is PC. It is 16-bit register used to store the memory address location of the next instruction to be executed, and microprocessor increment the program counter or program whenever an instruction is being executed. So the program counter point to the memory address and the next instruction is going to be executed. Next one, that is the stack pointer. So it is also a 16-bit register, work like a stack, which is always increment or decrement by 2 during push and pop operations. Now temporary registers, so it is 8-bit register which hold temporary data of the arithmetic and logical operations. And next one, that is the flag registers. Inside of the flag register, it is 8-bit register having a 1-bit flip-flop. 1-bit flip-flop means we are going to see, and which hold either 0 or 1s depending upon the results stored into the accumulator. Now there are 5 flip-flops that are: first one, that is the sign; second one, that is the 0; third one, that is the auxiliary carry; fourth one, that is the priority; and fifth one, that is the carry. Okay, so over here we can see that is D0, D1, D2, D3, D4, D5, D6 and D7. So in D7 we have as. As means it is going to indicate the sign. Either it can be negative or positive. So if it is positive, it is going to say 0, and if it is negative, it is going to indicate by the 1. So that is going to indicate the sign of the data. Then after 0, so if the data or the result is 0, at that time this flag is on, or we can say it is 1. Either it is not 0, then it is going to be 0. Then after this is the normal, and D4, that is the AC, that is the auxiliary carry. So if there is auxiliary carry, it is going to indicate 1, either it is going to indicate 0. Then after this is also blank. Then after D2, that is P, it means it is going to indicate the priority. So if the data have the priority, it is going to indicate 1, otherwise it is going to 0. And this is also blank. Then after D0, that is CY, and we can call it as a carry. So if the result is considering or result is containing any kind of carry, it is going to indicate 1, otherwise it is going to see 0. That is about the flag register. Then after instruction register and decoder, so it has 8-bit register. When an instruction is fetched from the memory, then it is stored in the instruction register. So instruction decoder decodes the information present in the instruction register. Next one, that is the timing and control. So it provides timing and control signal to the microprocessor to perform the operation. So to perform any kind of operation, we require timing and controlling, and the following are the timing and control signals which control the external and internal circuits. So control signals that are ready signal, RD, that is read write signal, and ALE, that is address latch enable. Then after next one, that is the status signal, that is S0, S1, that is going to indicate either it can be input output device or memory location device. Then after DMA signals, that is hold and HLDA. And last one, that is the reset. So reset in and reset out are the 2 reset signals. Next one, that is the interrupt control. So as the name suggests, it controls the interrupt during a process. When a microprocessor is executing the main program, and whenever interrupt occurs, the microprocessor shifts to the control from the main program to the process to the incoming request. So if there is any incoming request of the interrupt, so microprocessor stop its main program and process to that interrupt incoming request, and after the request is completed, the control goes back to the main program when it is left. Okay, so there are 5 types of signals in 8051. So they that are INTR, reset 7.5, then after RST 6.5, RST 5.5, and trap. Next one, that is the serial input output control. It controlled the serial data communication by using these 2 instructions, that is SID, that is serial input data, and SOD, that is serial output data. That's it. Next one, that is the address buffer and address data buffer. So the content stored in the stack pointer and the program counter is loaded into the address buffer and address data buffer to communicate with the CPU, that is central processing unit, and the memory of the input output chip are connected to these buses. So from these buses the data is going to be transferred. Okay, so the CPU can exchange the desired data with the memory and input output devices. Next one, that is the address and data buses. That is nothing but the data bus carries the data to be stored, and it is bidirectional, whereas the address bus carries the location. Address bus carries the location to where it should be stored, and it is unidirectional, and it is used to transfer the data and addresses through the input output device or the memory. And that's it for this video lecture. Over here we have some of the questions that are asked in GTU examination, so please note this down. And thank you. If you find any kind of query, then please ask me. Thank you.